Okay, Aria, so in this video I want to explain to you how we can find these different angle relationships based on the segment intersections. So here we will draw a circle. Let's just outline that. Alright, so this is our circle, right? And, oh brother, and right here is our center. If I can remember that. Okay, so right here is our center, okay? And let's say, oh, I don't know, this is circle A. Okay? So we already know that if this was a central angle, because the two radii come and meet in the middle, and they intersect at point B and point C. So by already knowing just that, we can tell that angle BAC is going to equal the minor arc BC, okay? Just don't bother about my bad writing. So we know that. So let's give this a measure. Let's say, oh, I don't know, it's 110 degrees. So if this was 110 degrees, what would this angle be? Well, we already know it'd be 110 because of the theorem. A central angle that intercepts an arc will be the exact same measure. Okay, but what if we don't have a central angle? What if it was, so there's these different types, right? So that was a central angle. Next we'll look at an inscribed angle. So basically it's a central angle, but as Mr. Lorenzo said, you just pull the radii, you just pull it back. So if I were to draw that, it would end up going from here to there, right? And so now it would also intersect at these points, and it would intercept the same arc of BC. It won't be, oh my goodness gracious, it won't be a central angle. It'll be an inscribed angle because the point where it meets the circle is, well, the point is on the circle where the vertex of the angle is. The vertex of the angle is on the circle at point D. So what does this mean? So if this was 110 degrees and we're trying to find this angle BDC, how will we find it? Well, the theorem says that if there's an inscribed angle, then it'll be half of its intercepted arc, which means that angle BDC is going to equal half of whatever arc it intersects. In this case, it'll be BC. So what does that mean? Angle BDC is going to equal half of 110. And so we'll get angle BDC will equal 55 degrees, okay? But that's in this case, right? Because it's an inscribed angle, we see that, oh, let me just change colors real quickly. We see that from this, oh, that's not changing colors. Let's go to blue. So we see from the original, where it was here to here, right? That was the hang on. No, stop it. What did I do? No, technology. Okay, so we see that, right? So it was originally from here to there, BC, and it intersected there, and so this would be 110. But then what we did was we ended up pulling it back to this new point, point D, and so now instead of it being this, it'll end up being half, which is going to be 55 degrees. Okay, but there's also another type of inscribed angle in the later section, and I can't erase this anymore for some reason. That's annoying. So in the later lesson, we see that there's also a different type of inscribed angle where instead of it actually being like this to a point there, to point B, C, and D, rather than it doing that, it actually ends up being a tangent and a secant, which means this is going to come here, right? And it's going to meet at this point. And then the line of tangency is going to come, meet at that point, and stop. Or I could just keep progressing slowly. But the point is that it's a line of tangency. So this is line of tangency. This is just M, and then we have B and C. Oh, I should probably give this a point actually. And so really it's, this is going to be D. Okay, so now we see that this is a different type of angle where this is the angle that we're looking for, and the intercepted arc is going to be I'm just going to put an E here to name it a major arc. If I can draw this. So really we see that it intercepts this entire arc here. It intercepts the whole thing all the way around, right? From point B to E to C. That's what it intercepts. And this is the angle right here. And this is what we're trying to find. Well, how? By the theorem, this technically is an inscribed angle. See, so this right here, oh my, why am I using black? So this right here is an inscribed angle by the theorem. And so by knowing that, we can say that, let's say that this was 220 degrees, okay? So that means arc BEC is 220 degrees. Well, because this is an inscribed angle here, and we can tell that angle BCD is going to equal half of its intercepted arc. In this case, arc BEC. Okay? And so what would that come out to be? That would come out to be BCD equaling 220 divided by 2, which ends up being 110 degrees, of course. And so that's what we see this angle to come out to be. And that's in this angle and also in the other one where it's not it's an inscribed angle where it's on the vertex. And so we see that this arc right here ends up being let me restate that. So this angle right here ends up being half of its intercepted arc, which is here. Just like over here, we see that this right here angle is half of its intercepted arc, which is BEC, the major arc. And so now that we see that, there's two more types of what you might call it. You know what I'm talking about. There's two more types of angle relationships in circles. The next one we're going to look at is the interior angles. Yeah, let's do interior angles. So with that, you'll need either two secants, which go like this to there, or you need two chords, which go from here to, oh, I don't know, there. It doesn't have to be. It could really intersect in any way. It could be here. It could be a diameter and another diameter. It doesn't have to be, though. It could be here and there. Really, it doesn't matter. So for the moment, we're just going to use two secants. No, we're just going to use two chords right now. And I'm going to get rid of that. So this is the center. We know that that's the center. Okay. We don't need to know that right now. So this is the circle, right? And they intersect at point A. This is B, C, D, and E. And E. Wow. Okay, so, sure. Okay, so what do we know from this? Well, because it's two because it's two chords that are they intersect in the interior of the circle, we know that each angle, so this and this, will be congruent. Because if you look, they're actually vertical angles. So angle BAD will be congruent to EAC by vertical angles theorem, and the same with angle BAE. It'll be congruent to angle DC by vertical angles. But the problem is, we can clearly see that, what can we clearly see? We can clearly see that this, oh my gosh, what am I doing? That this arc is obviously not congruent to this arc. I mean, look at the size difference here. And the same thing with this arc as well. They're not the same. They're just not the same. So because of that, we can't just say that, oh, that this is that this angle here will be half of this arc, because it may not be half of that arc, because it's this arc as well, because it's the same angle. So what do we do then? So what do we do? Well, the theorem says that one angle, so right now we're just going to look at BAC. In this, we're just going to look at this angle right here. Okay, so angle BAC will equal half of the intercepted arc that it has and its congruent angle intercepted arc. What I mean by congruent angle intercepted arc is that its congruent angle over here, this angle's intercepted arc, but because they're congruent, it's the same thing. So we're looking at this angle right here, and it's going to equal half of BC times arc BE, or plus, oh my goodness gracious, I cannot speak. Let's try this again. Arc DAC is going to equal half of arc, hang on. Oh my goodness gracious, I understand, guys. Okay, our angle DAC is going to equal half of arc DC plus arc DE. So let's just write that out real quickly. So we're going to see that, we're going to see angle DAC is going to equal, it's going to equal half of what? Of arc DC, I can't put the arc sign, of arc DC plus arc BE. So we see that this right here, this formula is this angle here, right? Half of equals half of DC plus BE. Okay? So let's look at this. Let's look at this real quickly. Oh my goodness gracious. Okay, so that's there now. Okay, so now let's write this out. If I were to say that, oh, I don't know, let's say that arc DC, that's the wrong color, isn't it? Yeah, it is. That's a shame. So arc DC here, let's say it's going to be, oh, I don't know, 54 degrees, okay? And that over here, BE, arc BE, is going to be 72, okay? So what do we get from that? Well, we already know by the theorem, so that means that this angle here, I'm just going to give this an easy now. I'm just going to call it X for now. So this is X. We are trying to find X, which is right here, this angle. So X, or you could also call it angle DAC, is going to equal half of 54 plus 72. And I'm sure if I had my calculator with me, which I do now, 54 plus 72 is going to equal 126. So X equals half of 126. X then equals 126 divided by 2 is 63. So that means, hang on, is 63. So that means that this angle is 63, and because it's vertical angles, that means this angle has to be 63 as well. All right, let's look at another one of these. Let's look at, if I could click Command Z quicker. All right, so let's look at another one of these with different. That's a bit different. So let's say we had this and this. No. Secants this time. If I can draw a line. So we have that, and we have this. And they intersect at point A, B, C, D, and E. Okay? And, wow, my handwriting is really bad, isn't it? This is a B. Okay? Okay, so I am going to make up some numbers, and I want you, Aria, to pause the video and solve it yourself. Alright, so the numbers will be, I want you to, okay, hang on, let me tell you what I want you to find first. That'd be helpful, huh? I want you to find angle BAC and angle DAC. DAC, okay? And I'm about to give you some... Hang on, let me just organize myself here. Okay, so I want you to find that, right? BAC and DAC. And I'm going to give you some art. Oh my goodness gracious. Okay. Enter. No. Okay. That didn't work. Where did it go? No. Alright, let's try that again. Perfect. White. Okay, so angle... Oh my Lord Jesus. Alright, cancel that. Just... Why are you doing this to me right now? Alright, so again, I want you to find angle BAC and angle DAC. Okay? And I want you to do that. The numbers will be arc DAE is going to equal... Oh, I found the text. Hang on, I found the text. Alright, never mind. Well, that's going to be there forever, but whatever. So I want you to find those. And arc DE, the small one here, is going to be 63 degrees. And arc BC over here, the small one, is going to end up being 21. And arc CD, oh, hang on, let me make sure this checks out. Okay, and this arc is going to equal 50 degrees. Okay? No, that doesn't look right. It's going to equal 110 degrees, okay? Let me just make sure my math adding skills are correct. Yes, okay. So I want you to find those and pause the video. Okay, I am assuming you have paused it now, and I'm going to show you how we find these now. And I'm just going to fail at doing that. Oh my goodness gracious. This is not working out as intended. Okay. So I'm going to assume you've paused the video now, and I'm going to move this over here so I can do some math. Alright, so now, because we know that angle, we need to find BAC. So let's look at this first. So BAC is right here, right? That's BAC. So we're going to see that BAC is going to equal half of arc BC and half of arc BC plus arc DE. So it's going to be half of 21 plus 63. And that comes out to be, if I could, BAC is going to equal half of 84. 84 divided by 2 is 42. So BAC equals 42 degrees. Okay, but now we have to find DAC, right? But wait a minute, we don't have arc BE. We don't have this arc. So how are we supposed to find it? Well, you could always just do you add these three up, arc BDE, you add all these measures up, and subtract it from 360. So let's do that now. 110 plus 63 plus 21. We get 194. So BDE, our major arc BDE, equals 194 degrees. And 360 minus 194 equals 166. So now we know that because we have this whole thing, we added up and we subtracted from 360, now we know that this arc BE here, is 166 degrees, right? Right. All right, so now that we know that, now we can just go ahead and find angle DAC, which is right here. So to do that, we just do angle DAC equals half of arc CD, which is 110, plus arc BE, which is 166. And so arc DAC is going to be half of 276, and half of 276 is 138. So if you didn't get that, I encourage you to look back and see what I did. 138 degrees. We got that there and that there. So look, so that's how you do it, right? But there's actually another way you could have done it. So we see here that, I need a new color. All right, whatever. So we see here that we found this angle right here, right? It ended up being 42 degrees. Well, there's also the linear pair theorem here because these two have to be supplementary. So 42, so we could have just done 42 plus angle DAC equals 180. And so DAC, if you do the math, 180 minus 42 equals 138 degrees, which is what we got. So really there was more than one way to do this one, and that's for all of the interior angles theorem problems. You just have to find one of them, then you can just do linear pair, linear pair, linear pair, linear pair to find the other four. So, or just find one vertical angles and find the other two with linear pairs. So really it's not hard if you think about it. I understand it is kind of confusing when she's explaining it fast. Okay, so next I want to look at the final pair, or the final angle relationship, which is, if I could clear this, is going to be the exterior angles. Yay! And so from exterior, I mean, we could really, hang on. Let me clear this again. So really, we could have three different circles here if you think about it. We could have this one here, which has two secants coming out, and they intersect here at point A. Well, hang on. Let's look at one at a time, okay? It's going to get confusing if I just throw them all at you. I understand. All right. So there's a few different ways that they can intersect to make exterior angles. The first way we're going to look at is when they intercept when the angle is out here. So we have two secants, and they go all the way through. So we have A, B, C, D, and E, okay? And it intersects these two arcs of BD and EC. So these are the two arcs that intercepts, right? Right. This is kind of similar to the interior ones. The only difference is rather than adding them, you're subtracting them, and by that I mean, so we have this exterior angle here, right? So by that I mean angle A. Let me just write it out. Actually, that might be easier. So by this theorem, we know that angle DAB is going to equal half of arc EC EC minus, see it's minus arc BD, or DB, whatever you want to call it. And because it's minus here, we see that it has to have the bigger angle, or the bigger arc, subtracted from the smaller arc. Otherwise you'd have a negative angle, and we don't really want that because that's pretty impossible. So it has to be the bigger angle and the smaller, minus the smaller angle. And that's really in all three. So really, you can always tell the bigger arc because it's the one farther away from the angle, right? Right. So if you look at it, this arc here is farther away from the angle than this one is, right? Right. So whichever one is farther away from the angle is going to be the bigger one, because if you think about it, it's going to open up as the angle progresses. It's going to open up. It's not just like an angle doesn't do this, because then that's just weird, because that's not an angle. But anyways, so we know that. So we know from this one that half of this plus this equals this. Okay? Okay. So let's look at a problem. Let's say that EC was 22. What? No, was 50. I keep using 50. Was 78 degrees, and DB was 11. Okay? Let's just say that. What would this angle measure be? Well, it'd be angle, oh my goodness gracious. Angle DAB is going to equal half of angle, or of arc, the bigger arc, which is EC, which is right here, is going to equal half of 78 minus the smaller arc, which is 11 in this case. And we're going to get angle, I'm just going to jump down here because there's not enough space there. So angle DAB is going to equal half of 78, oh my gosh, I can't even read that. So it's going to equal 78 minus 11. And so 78 minus 11 is going to be 67. And half of 67 is not going to be a completely, it's going to be a decimal. So 67 divided by 2 is going to be what, 33.5? Yeah. And that's going to end up being 33.5. So that's how you do it in this model. Really, it's the same in all these models, but there's two other ways that these can intersect with different lines. So that's this way to do it with this type of exterior angle. We're now going to go look at the next one. The next one is going to be, all right, so let's see. The next one, it could be a secant, right? A secant, and, oh, wait a minute. Oh, yeah, and a tangent, okay? A secant and a tangent. And they still intersect out here. So this is A, oh my lord. This is A, B, that's a secant. A, B, C, and then it intersects here at point D. So really, this is the exact same thing as the other one. So we have this angle, DAB, which turns out to be the same angle as the other one. And it's going to be half of what? Well, really, it intersects two arcs. It intersects this arc here of arc DB and arc DC. And just, I'm pretty sure, no, major arc would be like if it was over here and all the way around. Okay, so we have that arc there, and then we also have this arc here. Those are the two arcs that these are the two arcs that it intercepts. So really, it's just the same thing if you look at it. So let's look at it. So it's going to be angle DAB is going to equal half of, again, the bigger arc, which is D. Oh, I didn't give it. I forgot to give it a measure. This is going to be 127, and this is going to be 77. Okay, so 127 Oh, I changed it. Oopsie. So it's going to be 127, which is the larger arc, DC, minus the smaller arc, which is 77, right? If I could, there we go. Okay, so that means that angle DAB is going to equal what? It's going to equal half of 127 minus 77, which is 50 degrees, right? Right. So then DAB, in short, ends up being, angle DAB is going to equal to be 25 degrees, okay? So you understand how we got that, right? Okay, good. Now, at the end of this, I am going to do a short review of everything that we just did. All right, so the next one is going to be the final way that these lines can make an exterior. Oh, I forgot to draw the circle. That might help, huh? The final way that these lines can intersect is with a tangent and you guessed it, and a tangent. Okay? So A, B, and C. Okay? So really, this is the last way that it can really intersect. We see that it intercepts two arcs, which these two arcs together is going to be the entire circle. So arc CB, and oh, I should give this one CBD, and arc CDB, which is the major arc CD and B. So that's this whole thing, right? But it's the exact same thing as the other ones. So let's give this a measure 360. I'm just gonna hang on, let me do this real quickly. Minus. So this is gonna have a measure of 264, and this is gonna have a measure of 96. Obviously, it's not drawn to scale, just bear with me. Okay, so how do we solve this? The same as all the other ones, actually. So angle CAB is going to equal half of the major arc, which is C. The major arc, oh my lord, the major arc, which is CDB, which is 264. So 264 minus a smaller arc, which is here, which is 96, minus 96. And we just do the exact same things. This thing, 264 minus 96 is going to be 168, but then we still have to take the half of it. Don't forget, we always have to take the half of it. So CAB is going to actually end up equaling 84 degrees. So we see that this angle here is 84 degrees, okay? And that's all of the angle measures, or those are all the different types of ways that, oh my goodness, all right, hang on. So these are all the different types of circles they can make. So here I'm just going to draw a few as a recap. So up here we have this one, then over here we have this one, then over here we have this, oh my Jesus. And over here we have this one, and over here we have this one, and let's see, so here we have, so here we have the central angle, right? Here we know that this angle, hang on. Here we know that this angle is going to equal, because it's a central angle, because it intercepts, because the radii are meeting at the center. So we know that this angle here is going to equal this arc that it intercepts here. The next one was the inscribed angles, and there's two different ways. Oh, I'm still in red. And there's two different ones. There is this one, which is essentially this one just pulled back. So it's like this. There you go. Okay, this is the This is the center of the circle. Okay, this is the center. So essentially we see that this angle here equals half of this arc. It equals half of its intercepted arc. Right? Okay, so it's only half of it. Same thing with the next one, and that one was a tangent. Oh, brother, hang on. Let me draw this. So it was this, and then there was line tangent just right there, right? And we saw that this whole angle all the way up here was equal to half of this whole arc here, the arc it intercepts. And that was the end of the inscribed angles. Then we moved on to the exterior angles. And so we have this center here. We're gonna have, oh no, wait, we did the inscribed angles, or the interior angles yet. Okay, so the interior angles, there was this here, and oh, I don't know, that should pass through there. And we saw from this that these two angles were congruent because of vertical angles, and these two angles were congruent by vertical angles. And so these angles, this angle, oh my gosh, why am I in red? So this angle here was half of this arc plus this arc. Okay, so basically the arc that this angle intercepts and its opposite arc, not the adjacent ones, which would be these ones, but the opposite arc that its congruent angle intercepts. So that's what that is. Same thing with the red ones, with the other ones I marked. So these ones here would be half of this arc it intercepts here, and it'd be half of that arc plus half of the other arc that is opposite it, or should I say that is congruent angle intercepts. And then we went on to the final three, which were all exterior angles, which I will quickly fail at drawing, as you can see, which I will draw here. And so we have that now, right? Right. So we had the three centers here, and now let's look at one at a time. So from this one, the first one we looked at was one of these. So the secant went through, wow. So it went through and it intercepted outside. And so we saw that this angle here was half of this angle, the arc, I'm sorry. This angle here was half of the larger arc minus the smaller arc. And as I said, the larger arc is always the farthest arc away from the angle. So this is of these two angles, of these two arcs. So the farther arc will be the one farthest from here. So this angle was half of the larger arc minus the bigger arc, or the larger arc minus the smaller arc. Same thing with the other ones, and the other ones we had a tangent line come down, and then we also had a secant go through it. And we saw that this angle here was half of, again, the larger arc minus the smaller arc, which was here. So so this angle here is this one, the larger is the farther. This angle is half of the larger arc, which is over here, minus the smaller arc, which is here. And for the last one, it was basically the same thing, only it was two tangents. And so that went through there. Oh, look, my mom just texted me. That's nice. No, I don't want to go to Safari. And so then we see that, and also again we see this angle, and that's going to end up being this angle here is going to end up being half of the larger arc, which is here, minus the smaller arc, which was here. I should probably use different colors because it is the entire circle. So this angle was half of the larger arc minus the smaller arc, which was here. Okay, so that's what that was. I encourage you to go and do some problems in the math, like the study guide and review or something, or like some problems from there. I'm also going to make up some problems right here if you want to test them. I suggest that you just pause the video for the duration until you finish the very last one as well, because as soon as I finish raking these, I'm going to wait 5 seconds and give the answers. So in this circle, oh wait, let me call this one. This is number 1, 2, 3, 4, 5. Okay, so in this one, we're going to have a central angle, and the measure will be, and I want you to find, oh brother, A, B, C. Okay, and this is going to end up being 96 degrees. I should probably write this better. 96 degrees. Okay, the arc itself here is 96 degrees. Okay, and I want you to find here. Okay, so what I'm going to do is, what I want you to find will be in red, and the measures of whatever I leave will be in blue. So I want you to find this angle here, angle BAC. Okay, so that's number 1. Number 2, I want you to, I'm going to mix this up a little. I want you to find hang on, let me just oh brother, where's the eraser? I'm just gonna leave out this center for this one. So I want you to find the measure of this angle here. You can just fast forward to where I have finished these problems. Okay, I want you to find this angle by using what we have learned. I'm going to have this arc here. Arc DC is going to be 210 degrees. Well, hang on. And then this over here is going to be 100 degrees. Okay? I want you to do that. Arc BD is 100 degrees, and this is 210. I want to make this as neat as possible, which is really hard for me to do. 210. That was even worse. Oh my Lord Jesus. That's 210, okay? And I want you to find that angle, angle BAC. For 3, I want you to find this. Now, I don't want you to assume that any of these meet in the center of the circle, unless I put a point there and I say that they meet in the center of the circle, in which case then yes, they meet in the center of the circle. And in this one, I want you to find this arc, this angle right here, okay? And this is gonna be 70. And this is going to be 150. Using what you have learned, I want you to find this one right here, okay? Oh, I'll probably just put in another one as well, just to have some fun. And this is going to end up being 80. Yeah, okay. So I want you to find angle EAD right there, okay? That's a weird thing. Oh my Lord Jesus. All right, I'm gonna have to change these. The numbers will be in oh my Jesus Christ. The numbers are now gonna be in yellow, so you can distinguish between whether they are the number or they are a measure. Okay. Those are the three. Okay, right. And then there's the next one. For this one, I'm gonna make it go through the center. Oh, no, I can't for this one, actually. I can't. Okay. A, B, C. And I want you to find the measure of this arc. Okay, I want you to do that for me. And this angle is going to be 72 degrees. Okay, that's for 4. And for 5, I think I'll throw you off a bit. Put in some extra things. Okay. Oh yeah, and this as well. No, that wouldn't make sense. No, okay, never mind, hang on. Let me think of this last one. Center angle. Okay, and this is A, B, C, D, and I want you to find the measure of this arc right here. Okay, and the measure of this angle. Oh wait, no, hang on. Would that even work? Oh my gosh. These lines are parallel, okay? And this is going to end up being 70. No, it has to be way more than 70. No, it could just be 62 degrees. So this arc here is 62 degrees from, oh, I didn't, oh, hang on. I didn't, E, okay, so arc ED is 62. And I want you to find this arc right here. All right? Okay, so pause the video and I will wait 5 seconds and then I will start revealing the answers. Okay, well, I have assumed that you have paused the video, and now I am going to explain to you this. So, for number 1, what do? Well, because this is 96 degrees, this arc right here, because we know that this arc right here is 96 degrees, well, and we're given that this is a central angle, we can easily find by the theorem that this arc is also 96 degrees. So that one was an easy one. For this one, we kind of had to do a bit of work. So we needed to find angle BAC. We were given that arc CD is 210 and arc BD is 100. And so really to do this, you needed to do 210 plus 100 and subtract 360 from that. And you'll get that this right here would end up being, I'm going to put my work in green, this right here would end up being 50. And then to do this, you do the measure, so you do this angle right here, this whole angle, do my work in the corner. So I'm going to do my work on this side. So this angle back, BAC, is going to equal half of 210 minus 50. Why is it minus? If I could draw a minus. Why is it minus? Well, because it's an exterior angle. And so angle BAC is going to equal half of 210 minus 50, which gives us 80. So really for this angle, I'm going to write it in red. For this angle, you should have gone 80 degrees, okay? And yes, okay. So now that we have that, I am going to erase this quickly. Okay. Oh my gosh, if I could just, there we go. Okay, there we go. That's better. That's amazing. Okay. Oh no, I feel bad for that one now. Okay. So now we have solved number 2, and my computer just told me it's 8 o'clock. So I've been working on this for a while now. I will quickly wrap this up. Okay, so for this one, for 3, you're given this one. This was 150, right? This one was 80, and this was 70. Again, you could have just done angle DAC equals 150 equals half of 150 plus 70. And from that, you would end up getting 150 plus 70. You'd end up getting 110. So this would end up being 110 degrees. And you could do linear pair, subtract from 180, and you'd get 70 degrees, right? Right here would be 70. Or what you could have done instead of that was, let me just write 70 here. What you could have done is actually done 150 plus 80 plus 70. That's 300. 360 minus 300 equals 60. So then you would have found that this arc right here, was 60 degrees, right? We would have found that. And then you could just do, to find this angle, you have to do the angle relationships, which would be half of the arc BC, which was 80, plus the arc ED, which was 60. And what do you get? You end up getting 70. So really, either way you did it, you got it 70. So that's good. For 4, this one was fairly easy. It was the inscribed angle. So really, to do this, all you had to do was take this angle measure, double it to get the arc, and the arc, because, well, why? That's the question. The reason is because we know that this inscribed angle will be half of arc BC. So if we did angle BAC equals half of arc BC, right? Right. But we have the angle already, but we're trying to find arc BC, correct? Correct. So really, what would you have to do? You just have to multiply by 2, and you'd get arc BC equals 72 times 2, which is 144 degrees. And hopefully, you got that. If not, it's all right. You just got to just text me if you didn't get it right. It's all right. Or just look over the video again, or look in your book. It'll tell you there. Okay, so now we're on to the very last one, which I tried to make as difficult as possible. Okay, so we were given that this was, why am I white? So we were given that this arc here, ED, was 62 degrees, correct? Correct. And angle ECD intercepts this arc. So really, we would see that this is an inscribed angle because its vertex is on the circle. So then we see that this would end up being, this angle here would be half of that. So then this would be 31. But wait, I put in the extra thing that these two lines line line CD and line AB were parallel, correct? Correct. And so from that, we know many things: alternate interior angles, alternate exterior angles, and some other ones that I forget. And so because these are parallel, we know that this would be congruent to that by alternate interior angles. And so this would end up being 31 degrees as well. Okay? And we needed to find this arc of AC. Well, we see that angle ABC intersects this arc. So really, all we had to do was do the same thing as we did in this one, really. So angle ABC equals half of arc AC, correct? Correct. And we get 31 equals half of AC. Okay? If I could... Okay? Hang on. So 31 equals half of AC. So to find AC, we just have to multiply again. So in AC, you would get as 62 degrees, which really ended up being the exact same as this one over here, which I did not know until now because I'm smart like that. Wait, did I say 62? Yeah, 62 degrees. Because 31 times 2 is 62. So that's how you do those. If you want, I could give you some more problems. I could help you some more tomorrow. But yeah, this has been angle relationships. I hope you understood. If not, give me a shout out. So hope this helped you. Love you. Well, that was a bit awkward. Well, I'll see you tomorrow, Aria. Bye.